All right, good morning on this rainy, icky, windy, stormy, yucky, horrible day. Um, let's take a look at a couple of things here. So week 13, we're almost to the end of this. So if I look ahead at my assignments, we're almost done. We're rounding out this semester. So this week due on the 17th, there are only 3 assignments, and that's actually on purpose. One of the things that will happen on Thursday is, and I've told the people in class here already, but just to reiterate, we're at a research day in the morning, so there will only be today's recording and then any additional ones I create for an assignment as we look at them this week. So, a couple of things to remember that are due this week then. So, 6.1, 6.2, and 6.4 are due. This is a practice. These are flashcards. This is a practice crossword puzzle, really just terminology. Those don't contribute to a grade, but what they do is give you some enhancements then for when you take the quiz for this week. And then there's an animation, which these are usually kind of an interesting little piece. They're a couple minutes long, so I encourage you to go look at the animations here. So I'm going to talk about a couple of items before we kind of launch in there. So we've talked a little bit about functions already. We've said, hey, I can define a function, and I know a little bit about it. And so we got your feet wet. And today we're going to go a little further in there about what's going to happen with some of these functions. So a function does a couple of things that are kind of nice. And what I really like about it is it gives us that abstraction. In other words, I can say to go do something, and I don't have to know all the details of it. So if I'm going to break up my coding, so maybe we did a class-wide project, and everybody in here was designing a piece of it, we'd set some ground rules, and then we might have 6 or 10 or 20 different people writing functions that do something that we call to them. So when I write my code, it also allows us to do things that are, I can call, so they use the example here of saying something about doing my laundry. So if I tell my 10-year-old to go do their laundry, they know what that means. I don't have to say, hey, go downstairs, take your laundry out of the dirty clothes basket, put it into the washer, and all these steps. We're eliminating that because we could just say, hey, go do your laundry. Or, hey, I'm going to run to the store. Or whatever task it is. So that way we can concentrate on the main programming logic, and we don't have to worry about that as much. So the other thing it does is it allows us to eliminate a bunch of repetitious code in our program. So if we know that something is going to happen repeatedly, so asking for user input, for example, is a good example of that. If we ask for user input, we know that we're going to do that repeatedly. So if we design a function to do that, we don't have to, every time in our code, reach out and get them. Or in this case, we're having a function called summation, returns the sum of the numbers from lower through the upper bounds. Well, we don't have to write all of this code every time we use it. The other one, not just redundancy, but that idea of complexity. So we don't have to go through, once we've created a module that does something like a countdown timer, and all we do is feed it in a time and a return, we don't have to revisit that every time. We've got that complex piece that's setting in a function. We know that we just have to call it. It's no different than when we call functions like a print statement. That really is a function. We're passing in what we're going to want output, but we don't have all the details of how that print function works, and that's okay because we know that it works and it functions right. Once we get something that we know it works, it functions correctly, we've thoroughly tested it, why recreate the wheel? So an algorithm, we've talked a little bit about it, and so we're going to talk that it really is just a method for solving a problem. You guys use algorithms all the time, whether you know it or not. You're faced with challenges in life. I need to go to the grocery store. Well, all right, I have to make decisions. Do I go to Nebraska City or do I go to Auburn? Auburn's a little closer. Nebraska City has bigger grocery stores. So we have to make up those decisions, and we use algorithms in our own life to do that. All right. So we talk about a couple of different ways that we can solve problems. Probably the biggest way, or the most common way, is this idea of a top-down. We look at the entire problem and we start breaking it down into smaller, more manageable pieces. Well, we do that all the time. And again, in your own life, you've run into situations where it seems like a very complex, daunting task, and you say, well, all right, I have to break this down. Maybe you've got to write a 30-page paper for Business 495. Well, that in itself sounds daunting, but then if you break it down into, all right, I need to write an outline, I need to write an introduction, I need to write, my body, and I need to do my research, and I break it down into pieces. So we've broken it down that way. We've done a decomposition, in other words, and we've broken it down into smaller and smaller pieces. So, one of the other things that we have that you can run into, and this is a term you'll see, is recursive. So in other words, recursive calls itself to do the same thing over and over and over again. So, a recursive function calls itself. So, in other words, we can create a loop of functions instead of having that loop inside of the function if we wanted to. So, sometimes that will be a little odd, and you'll see that sometimes it's not always the easiest way, but sometimes it's the best way that we can solve a problem. All right, so let's take a look. So you need to do the reading, you need to do everything else, but let's take a look really quickly at 6.1 and see if we can. If we can at least get a start on this and kind of take a look and see what we're working on this week. All right, so we have a math function. Package Newton's method for approximating square roots in a function named Newton. This function takes the input number as an argument and returns the estimate of its square root. The program should also include a main function that allows the user to compute the square roots of inputs from the user and Python's estimate of its square roots until the enter return key is pressed. All right. So when we start with this particular program, we need to figure out a couple of things. And one of them we need to think about is what are we doing? And we're trying to estimate some square roots. All right, so let's see what it looks like when we run it. So let me show this. Enter a positive number or enter a blank value to quit, essentially. So if we put in 2, it says the program's estimate is 1.41 blah, 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 blah. Python's estimate is this number. All right. So here we put in 4. The program's estimate is, wait a minute, and notice how we get a number that's not quite 2. So what we're doing is comparing those two with the value from our math function, compared it to a method we're using to try to get close to it. All right. So we can find some of these pieces. So So we know that the first thing we're probably going to have to do is we need to get the math function. If we're going to take the math function so that we can get a square root from Python, well, that's one way we can do it, and then we're going to write another method to define that. All right, so we have a couple of pieces in here, so it does give us this function here. Now, here's what I'm going to tell you about this and why it drives me crazy. So, estimate equals estimate plus x divided by estimate divided by 2. The difference equals the absolute value of x minus estimates, and then we raise it to the second power. So that formula is going to work for us. And then we have to look at this something called a tolerance here. So, all right. So, if the difference is less than or equal to our tolerance, then we're going to break out of this loop. So in other words, we've created a loop that runs until we get to some value here where our difference is less than, in this case, 0.00001. So one of the things we might want to do in here is we might want to do this. We might want to put a print statement in there, and we want to print estimate and difference. So now, what this is going to let us do is just see what's going on in this coding a little easier. All right. So I'm going to run this to start with, and I'm going to put in a number like 54. And as it runs, so we're going to get the estimate and the difference. So estimate, so what it really looks like it does, as we go through here, your estimate gets closer and closer and closer, and at some point here, we actually get the math.square root function, and so you can see that we're pretty close, all the way out to about 10 digits or so in here. All right, so if I run it again and I put in something I know, like 49, now we can kind of see how it's getting closer and closer. So it's not a function where it returns it automatically, it returns it then based as we get closer and closer and closer. So it's a function that leaps through those. All right, so our task, though, our task is to do a couple of things. So we're going to make this a function. So we're going to take this piece and we're going to make that into a function where it returns all of these pieces to us. So if I look at my directions, it says package Newton's method for square roots. So we've got that here. We need to create it into a function named Newton. Expects the input number as an argument and returns the estimate of its square root. Okay. So we're really modifying this code here a little bit. So we need a couple of pieces out of here. So we know that we're going to define a function called Newton. Define Newton. And we're going to take a value into Newton. So while true down here, we've used just the value x, right? Estimate plus x. So we're going to pass in a value of x. So Newton's going to take in this value and work through that, okay? So we could do the triple quotes down there. Oops, got my colon. successively get closer to square root. All right. So, one of the things we need to move down into this function is this line here where we say our initial estimate is 1. We can't see this value outside of this function, so unless I passed it in, we wouldn't know that it's in here. So it would tell me that estimate isn't used. So I'm just going to put it at the very beginning of my function. Because remember, I can't pass things through unless I'm sending it in. So I'd have to send in x and estimate. Since we always start out at 1, it doesn't make a lot of difference. All right. So the next thing I know I'm going to need to do is I'm going to need to indent those all so that I'm in the right function line here, or the right indent. So delete a couple lines to make this a little cleaner. All right, so estimate equals 1. Perform the operation, so that's not going to necessarily change. Estimate, so these are going to be the same. Our print statement in here, I'm going to leave for now. The only thing we need to really add, so we're going to break out of this loop. So I need to get back at the while true level, and we're going to return estimate. So we can pass that back into the function that calls it. So our function didn't change a whole lot. We had to add this return estimate and make sure that we're all in the right block quote. What might change, though, is a couple of other pieces. So output the result. So at the end of our output, we know that we want to have these results outputted. The estimate, and then we're actually calling the square root of this. But we need a main function. So we're going to define main. And main doesn't get anything passed into it. So we'd like this to repeat over and over and over again. So one of the easy ways to do it is put your main in a while loop. So while true. So this will loop indefinitely. And somewhere up here, where did we get the... There it is. I'm going to take this. Copy. I'm going to copy it. So while true, I need to get that value from my user. So I just moved it from up top and I moved it down into my main loop right here. So x equals the float of a positive number that we're going to enter. Well, I need to see if that number is a blank. And so if it is, so if x equals a blank, then we're just going to break out of that loop and just kick ourselves out. Otherwise, we need to convert it to a, or have we already done it to a float? Oh, actually, hang on. We got to do something a little different here. So I'm going to take this float out of here. So what that changes is that way that I can compare it to a blank input. If I already converted it to a float, it would try to compare it to a numeric. So x equals float of x. So we just converted in 2 steps instead of 1. Then we have our output. And I need to put that at the same level, so I'm going to tab those in. Alright, so now we've got our main function set up, and so we reach into our bag of hiding commands, and we have our constructor that will allow us to start our main program. So that underscored name equals main, then we run main. Alright, so this is just our, one of our pieces we keep all the time outside of our little box of copy and paste items. Now, there is one thing I'm kind of curious about here, and let's just see what happens when we run it, and see what other typos I made. That'll usually be the first estimate. Right? So when I run this, unexpected indent blot after while statement on line 39. Okay, so somewhere I did something weird here. Oh, okay, hang on. All of those need to move in one. There we go. Okay. Enter a positive number. Error name. Estimate is not defined. Okay, so that was on line 45. It really references it again. The program's estimate is, oh, we didn't put a call to, hang on. I didn't change those at all. So, the output is actually, what we really need to do is run Newton. It'd be helpful if I call the function that I wanted to use. Alright. So we call the function Newton here, and that should go back up and running. Hopefully. Let's try it one more time. Alright. That seems like it's going to work, because look, we have a estimate of 7 point, however many zeros and 2. Python's estimate is 7.0. Let's do a different number, 681 or something. And again, we're estimating through, and we get closer and closer and closer each time, and then we end up with, in this case, we end up with exactly the same number to that number of digits. Let's see if it works if I hit just a blank enter, and then it has kicked us out of the program. So, we could write some other pieces that said, like, hey, thank you for playing or whatever, but right now, it seems like our program is working and meets the conditions we needed here. So, let's go over it again really quickly. So, we didn't change the import math. We need that import math for our math.square root here. Now, we defined this method called Newton. We called it over and over again because we don't care how many times we do it. I'm going to take out this print statement, but I'm just going to put a pound symbol in there, or hashtag, to just turn it into a comment for now. So now if I run it, I just get the values. I don't get its iterative selection. So, our main we moved down here, so we took the actual program where we got an input, and we added it so it would create a loop and run essentially until we ended it, either by a control break or by hitting an enter key. Our print statements, we said, well, we're going to print. So we called our function Newton right here. And then here we called our math function dot square root. Now, could we make this a little better with some perhaps more descriptive names? Yes. So I might change this just x value, because x doesn't tell us anything. On a short program like this, we can see pretty quickly what it does. All right. Are there other ways to do this? Yes. But let's see what our grading scale on here checks out as. Let's see if it runs. Yay. So it does satisfy the grading requirements. There are a lot of things we could do to make this a prettier program. You could actually, do the absolute value subtraction to show the difference in there. We could run it with a really large number and see how quickly it comes up. And you can see that natively, we're pretty fast in there. It literally appears instantaneously, even if I put in let's try a really, really big number. So it estimates that and cycles through even before we get very far. So there are other things we could do. We could say we wanted to limit it to 3 or 4 or 5 decimals, and we could do all kinds of things. But this solves our issue, and it shows that there must be a different method that internally Python is using to get those square roots, because we have slight differences in some of these calculations. So, all right. So that is 6.1. And how we move that into a function from where we started at. So this tolerance determines how far out we go. So we would get a much cruder estimate. So if I took this down to 0.1 or something, we would get a much cruder estimate. So if I did the same thing again with, you can see that our estimate is now significantly different because we don't have as great of resolution. So that just sets how many times essentially you're going to loop that and how great that is. All right. So 6.1 hopefully isn't too horrible to look at. When I look at 6.2, come on, some time load. All right, so now we're going to modify this again. So the same function we had before, now we're going to take it and we're going to modify it just a little bit. So we have a program here. Now, here's what's interesting. If you would have looked at this one first, you would have had the solution for 6.1. This time, we're going to change it a little differently. So this time we're going to call a recursive function. So in other words, instead of doing all of these pieces together, we're going to come up and we're going to call this function from itself. Hang with me and we'll show you what I mean. So this isn't going to change up at the very top. Our tolerance isn't going to change. Now, one difference here is they said tolerance and they've done it all capitals, and that is supposed to tell us that it is a constant. Now, we know that Python doesn't really recognize that as a constant, but it tells us that that's a constant, and we're not going to probably change that. So, all right. So if we're going to define this as a recursive function, so we even get an example. Hint, the estimate of the square root should be passed as a second argument to the function. All right. All right. So if I'm going to pass that estimate back in, so maybe this is going to have to change to x, comma, estimate, because we're going to call this function from within itself. Oh. Okay. So let's revise this just a little bit. All right. So I'm going to take this out for now. So I'm going to keep some pieces of this, but I'm going to change it around in its order just a little bit. So I'm going to move this all the way up to the top for now. So, and I'm going to take estimate out of here completely, because we're going to pass it in the first time we use this program. So, don't let me forget that we have to put that in when we start it. So we're going to pass in estimate. We're going to do our difference, so we're going to see how close we are to the actual number. And so we're going to move this piece up here. So we're then going to ask our if question. So if estimate, or no, sorry, difference, is less than or equal to tolerance, then we're going to return that estimate. So in other words, return estimate. So we've found that this value is great. It's below our tolerance level, so we think it's a valid estimate of that square root. But if it's not, then we're going to hit the else clause. And this else clause is where it gets a little weird or different. So this is going to be our recursive piece. So if it's not, we're going to return. But what we're actually going to call is our Newton function. And we're going to pass x back in. And then we're going to take this math function that we used before. So, and I'm just going to do it up here. Plus x divided by estimate divided by 2. Let's see if I have that right. Estimate divided by 2. Okay. So we've taken that math function, and instead of having it in this loop here, so same function here, I've now put it into a return statement so that if our estimate isn't good enough yet, it's going to call this function again and run this function over and over again. So it'll function or should work exactly the same way and get us a value, but this might be a cleaner way to do it. We've taken out some of the other elements here. So we do have to change this just slightly. So instead of passing in one value, so in other words the value we enter, we're also going to enter an estimate to start with. And we said before that that very first estimate was going to be 1. So let's see if that works. So let's put in a number and see where I made some typos. Unmatched parenthesis line 26. All right. Line 26. Return Newton of x, estimate plus x, estimate. What have I done? All right, somewhere I've got an extra. All right. See if I fixed my extra parenthesis. Indent level line 29 does not match. Somehow I indented that. And there. Enter a positive number. So I'm going to put in 25. The Python's estimate is 5 point blah 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 blah. Python's estimate is 5.0. Alright, so let's try a bigger number. So you can see it works very similarly. And again, our numbers are close. They're not always exactly the same. Now, I broke it here because I put in a negative number. And right now we don't know how to solve for negative numbers this way. So a negative number in a square root has to have the imaginary way. Anyway, it doesn't matter. But it will return us numbers. And we really didn't make a lot of changes, but I want to make sure we understand what the differences are here. So we can pass more than one argument into a function. So in this case, we call the function Newton, and we pass in the value of x, which is our input, and the value of 1, which is our first estimate. And you could change this estimate. If you wanted to try something, you could change it and see what happens. And it eventually ends up with the same number. It just may take additional steps. But let's go back to our 1. All right, so we're able to pass multiple items into a function. So here we've passed in x and estimate, but they're not the same names, right? We passed in a value of 1, but here it's called estimate. Because we're sending it to a function, it could be a completely different name. Because what we're doing is passing the value of 1 in here. We're passing the value of x up here. It doesn't have to be the same name. And we can prove that really quickly. So we could change this to y. And the program's estimate is... So we're not passing that the content of that variable, or we're passing only the content, not the variable. So now if I run it, oh, hang on, we don't have a, I need to change it one more place to do that. It's hard to compare when there's not a value in there. Okay. And notice I've changed that to y. It's not passing the variable, it's passing only the data that's inside of that variable. So that's our 6.2. So in other words, we're trying to learn how to pass a couple of things. And the most interesting part is we can call this function within itself. Now, I probably could have made it easier. I could have come up with another variable here, you know, and come up with z or something to put this in a statement above it. But I can put that math function right in, and so it's going to calculate what that values are and send that back into Newton. And so it just keeps looping this until this condition happens. All right, let's take a look at 6.4 and see if we can get a good start on it. All right. So now we're going to put this into 3 functions. So the same type of problem to start with. So if you notice here, we started with our original program here, and we're going to break this into 3 different functions. So we're going to have one called Newton, one called limit reached, and one called improve estimate. And again, the output's going to look very, very similar. So we need 3 functions: Newton, limit reached, and improve estimate. So what these are going to do is one function is going to call another function is going to call another function. So let's see if we can start on this. All right, so import math, yep, that's still fine. we need to define a main. And so our main, I think we can actually grab very similar to what we had before. So let's do this. Let's define our main first. And our main, we're going to still use the same piece, so let's see if I have it there. We're going to cheat and grab our previous content, because I think it'll work just fine. So, if you remember, this is from 6.1, so x equals input, so we've created a loop here to start our function, and we check to see if you want to escape out of that loop. We created a float of x, and then we passed it into Newton, and we passed it into our square root function to compare them. Alright, so I'm going to tuck these down a little further for now, because the other piece we need, and again, I'm going to go to my text box full of handy pieces. So if I grab the entire line, I'm going to do our beginning to our program. So, I don't need these statements at all. So our main doesn't seem much different, because our main is still going to pass it up to a function called Newton. So this should be very familiar. We're going to start the program, will auto-execute because of this line. Now we need to break this down into 3 more functions. All right. So let's see. Receive the input from the user. We do that one up there, so we can get rid of that line. Just going to get rid of some stuff as we modify here. All right. So we're still going to have the tolerance and the estimate. We may use them a little differently, so we'll have to look at that. And I'm going to leave my math functions here for now, because we're going to use those. So I know I need to define a function called Newton. And Newton's going to take that x. In this case, it's also got to get a value in there for estimate. But instead of passing it, or we could pass it either way, but I'm just going to do it this way. Estimate equals 1. And I can put that up in there. So it's just, there's a lot of flexibility about what we have here. So that means every time this function is going to have our value passed into it, and then the estimate's going to start at 1. Alright, so alright. Now I need to figure out how I can break this up even further. So I know that I'm going to have another function here, and I'm just going to back out here for a second. I'm going to have a function called limit reached, and I'm going to have a function called improve, make it all one word, estimate. So I'm going to put all 3 of my functions down here real quick so I can see what they're going to do. So I'm going to call these functions, so limit reached and improve estimate, from my Newton function. So instead of doing those calculations inside of just one function, I'm going to break them into several functions. So it's not going to look a lot different than what we did before, but it will be a little different. So I'm still going to have an if statement. So And I'm going to call this function, so if limit reached, and I'm going to pass in the value of x and estimate. So if that is true, all right, I'm going to return estimate. So if my limit is reached, in other words, with that tolerance, then I'm going to return it. So in other words, to do this then, limit reached, I'm going to have to take in a couple of values. And I'm going to have to take in x and estimate. And again, I could use other names for them, but just so I can keep track of where they're at, I'm going to use the same names. I can't just pass the variable in, though. I have to pass in the number. So returns true or false. All right. So here I'm going to take my difference, and I'm going to put it in this function. So difference equals absolute value of x minus estimate squared. All right. And then I'm going to return if difference is less than or equal to, now, I think I am going to change one thing up here, just because I like the idea of making sure that we see that as a, I'm going to do this. So, just to make it a little plainer. All right, return difference if it's less than or equal to tolerance. All right. So this will pass back into this function. So in other words, we're passing a piece back up. Now, the other piece we have then is this improve estimate. So this function is going to modify our estimate, and it's going to return then this portion. So it's going to return this. So in other words, we've just broken this up into some subsections. Alright, so let's look through here. If limit reached, return estimate, else, so at our, oops, come back up here. So where we had our else before, now we need to go in and call that function again. So we're calling Newton just like we did before, but we're now calling a function also within that. So that's where we're going to call that improved estimate, and we're going to pass in x, comma, estimate to that one. All right. All right, let me scroll through here and see what we need to get rid of and make sure we're in there. So that we've taken all the pieces of. So take a look through here and see where I have some hideous typing errors. Hopefully I can spot them quickly. All right, so we've defined Newton again. We've changed it just a little bit. In fact, I'm going to eliminate that. All right. So we've just passed estimate 1 in the first time this function calls itself. All right. So we'll see that as we go, it's going to change over time. Limit reached is a function. Improve estimate's a function. That should be okay. All right. Here's the always scary moment. We're going to push the run button and see what happens. Invalid syntax, line 28. All right. What did I do on line 28? Ooh, why did it not like that? Okay. Oh, because I'm passing. Yep. Yep. All right. Yeah, and if it were an empty function, it would also need to just have the. Got to say to myself trying to do that. Line 30. What have I done on line 30? Return estimate invalid syntax. Something silly on there. Return estimate equal. What did I do that for? Where did I type that? Oh, I tried to just copy it out. Okay. Let's try it again. Let's delete all this and start over. So return. No. Let's run it. Unexpected indent. Like that. I copied that and I may have done something. See if that's at the right level now. X equals nope, I don't want to do that. Nope. Need to go backwards. There we go. Okay. Line 36. No, it doesn't like something in there. Open it up so I can see it here a little easier. What does it not like about my indent? Break outside of a loop. Oh, I don't have my while true in there. That's what I, okay. Alright, so now all of that has to indent once. Okay. Well, let's see if I made it happier. Yay! Alright. Alright, so put in a value in here. So program's estimate is Python's estimate. So we know what our 9 shows up. So we know that we would have to increase that a little bit, but it's the same answers we've been getting, and we've broken this up into three different functions here. So Newton, not only does it ask for another function, so it goes down here to limit reached, it also then, if that doesn't work, then says, oh, otherwise we're going to come back and run our own function again, including calling this improved estimate. Now, would we really break a function down this far? Probably not. It makes a good exercise. But do we have functions calling each other repeatedly? Yes. Do we have functions calling themselves repeatedly? Yes. So this is just a really good example of how we can break these down. It's a good example of how we can pass details in and out of them. So here we pass in the value of x. And again, we could go through that and change those all to y's, and it doesn't matter because what we're really passing in is that value. So I could change it here where it said y equals the float of x, pass in y and y, and it's not going to change the program itself. So we've just broken it down into functions, and we're breaking them down. So the recursive piece is a little weird. At first, what it allows you to do, though, is save a lot of loops inside of functions, because instead of looping inside of the function, you just call the function repeatedly. So, sometimes that's a better method. Sometimes the loop inside of it's a better method. It just depends on what you're trying to do. This very commonly we do. So another way we might do it is actually instead of having this loop inside of the main function, we might just loop the main function, and so while true, then we would run it. Otherwise, we would change it. So a lot of different things to run through in here this week. So let's look at our discussion board. So for this week, I eliminated the discussion board. Yay! So I noticed that a lot of people have not done last week's discussion board, which was an assignment. So I would encourage you to go back and do that really quickly so that I will give you points for that. So, get that. All right. So again, places to look if you're confused or you're looking at things. These coding snippets are a really good way to practice different pieces. So they have all these kinds of things in them. Converting between dictionaries, looping, and else clauses, nested statements. So defining a function, scripts versus functions, functions that returns values. So again, if you need some practice on that or you want to see how they're done, because sometimes, myself included, I work better off seeing what we can do with them. Than rather reading in a book that says, hey, you need a return statement, if I see an example, so if I come in here and I look here and I say, all right, I see that this snippet, well, okay, Cengage, there it is. So here we have a function called absolute difference, which takes in number 1 and number 2, and says, what's the difference of those? And then it returns it as an absolute value. So I have two numbers here. It passes them in, tells me the absolute return. So if I run this, I'm not showing the screen here. Run. So we can see what it would do on this particular little snippet. So I like examples. That seems to be a better way for me to see things. So all of these different code segments in here are a great way that we can look at those. So let's look at our future. So there are only a few weeks left. So we have week 13, week 14, week 15, and then we take a test. So we will have some study review pieces for the test. The test will have some coding samples in it. You will not have to code a giant piece in there, but there may be things to try to run and execute. So one of the things I will point out when you copy and paste, as you've seen here when I paste even out of a notepad in there, like my ending statements, sometimes that pasting will screw up my indenting and I'll have to double check it. So make sure of that when, something will remind you again about when we get closer to the final for that. All right, any questions? All right. This would be a great week since we only had these 3 assignments to get caught up if you're missing anything. If you are missing anything and it's already got a 0, you will need to email me so that I can clear that override grade. All right, any other questions?